Okay, class, we're still on set number 2 here in lesson 6 of chapter 6. We're on problem number 7, and we're told to write the equations for the lines labeled A, B, C, and D in the graph below. So here we have a graph with a bunch of lines all over it, and we're wondering, what are these equations? Now, before we did this chapter, I asked you to do that, and you would probably just look at me and say, how? Well, you've learned how in this chapter, and in particular, you've learned slope-intercept. And let's go ahead and write that back up there on the board. Y is equal to AX plus B. We write our form, and we know that A is the slope, right? We know A is the slope, and B is the y-intercept. So as we look at our graph, we're looking to determine what the slope and what the y-intercept for each of these lines. And if we were to take A, and just take a look, I don't have it here on my board, but you can look on your textbook. And if we were to look at A, we would notice that it crosses the y-intercept at 1, 2, right at positive 2. So I have a y-intercept. Let's get rid of that line. And I have a y-intercept of, we know the first part of the puzzle is that it's crossing at positive 2, so that would be plus 2. What we need to determine now is the slope. And what would be the slope? Well, if we were to start there, we can take any point, but being that that's a point that we can determine of being 0, 2, let's go up and try to find the slope to the next point, which I see is kind of just above the other line C that crosses across the page, and I see that it's actually a whole number there. So if we went up 1, 2, up to 5, and over 1, we would find that our slope is 2 because it's up 2, rising 2, and over 1. And we know that 2 over 1 is equal to 2. So in this case, our slope would be 2. So we found the slope and we found the y-intercept just by looking at the line. So you can go ahead and do that with the lines that you're presented, and that would be your problem number 14. And we don't really have to do all of these. It's just simply work, and your mind has to be put to the task of applying knowledge to determine what the answers are to these problems. And we could do these quite a bit, but really the only way you're going to learn is by doing it yourself. So it's very important that you do your homework, and that's why we've put that emphasis here. I'm just simply guiding you through some of the problems here. Now let's take a look at number 8. Graph the following equations by using their y-intercepts and slopes. So now it's the opposite. We're going to simply take the slopes and the y-intercepts off of these and graph them. If we were to look at A, y is equal to 2x plus 5. Well, my y-intercept is plus 5, which means I'm here. All right, on my y-axis, it's the y-intercept. It crosses here. And I know my slope is positive 2, which means I can go up 2 and across 1. Up 2 and across 1. Right? That's 2 over 1. I can go down 2 and across negative 1. So down 2 would be negative 2 divided by negative 1. Negative 2, negative 1. And you see that I'm still in that straight line. So then I would just take my ruler, and I can go ahead and connect these, and there's my graph. Okay. And again, doing these for each of these, just a simple exercise. You'll have that on problem number 15. A point, to number 9, a point moves so that its y-coordinate is always 5 more than its x-coordinate. Okay, now we're going to have to figure out what our equation is for this particular, and this is the challenging one. Now we're sort of building the complexity. I'm going to need to erase some of this here, and just so we can build our equation and follow the rest. Now I tend to always keep my y is equal to ax form on the board. Typically everything points to that, so it's good to have it in front of you, and being able to see it will help you to simply memorize it. Now Question number 9 asks us, it says a point moves so that its y-coordinate is always 5 more than its x-coordinate. So we would have to think its y-coordinate is more. 5 more. So wouldn't that be x? Its x-coordinate, right, is being added to 5 so that the y is always 5 more. Y is equal to x plus 5. Okay, y will always be 5 more. So let's putting in a value for 1 of x. Y would be 6, and that's correct because y would be 5 more than the x. And you could put in 2, it would be 7, 3 would be 8. Now, we have the equation. We now need to graph its path. Well, we know that the slope and the y-intercept are contained. It's already in the slope-intercept form. In fact, we can just put a 1 in here if we'd like, just to feel a little more comfortable that we know what the slope is. And we can go ahead and plot our point, 5, right? So we're going to graph this, and we have a 1 slope, which is again positive. It's going to be moving in this direction, not downward. And this was a simple one because it means 1 over 1, 1 over 1, 1 over 1, 1 over 1. And we can go negative 1 over negative 1, negative 1 over negative 1, negative 1 over negative 1. And you can see we have a line here. We can just go ahead and graph that. We've plotted points, but graphing means that you need to connect the dots, so to speak. And let's go ahead and with our ruler just graph it. So we have our graph now. Now we're being asked where does it cross the x-axis? Well, it crosses the x-axis where we didn't cross it yet, did we? Because we didn't really quite go all the way down. So let me just grab this and bring it all the way down. Where does it cross the x-axis? Well, it crosses it right there at negative 5. So our coordinate would be negative 5, 0. So we'd move all the way over negative 5, 0. So that's where it crosses the x-axis. And where does it cross the y-axis? It crosses it at 5, 0. Okay, and the question is, what is its slope? And we determined that already when we were looking at the form, and the slope was equal to 1. Okay, and moving on to number 10, I'm just going to clear this board here up real quick. And moving on to number 10, we're going to have an exercise about a rectangle where we have we can see that the sides are 2 and x. So if we were to write an equation for its perimeter y as a function of x, all right, we're going to write the equation. Well, what would the perimeter be? We understand that the perimeter is by adding. We determine that by adding all the sides, right? So we would have y is the perimeter is equal to, and we can just go ahead and add them all up. 2 plus x plus 2 plus x. We just went around. And, well, what's that mean? Well, it means that we'll have 4 plus 2x, and we can write this in slope-intercept form by putting the x first, 2x plus 4. Okay? So we now have our equation. We can graph this. How do we graph it? The same way we graph the others. And we can find our x, where it intersects the x-axis, which is the x-intercept, and we can determine the y-intercept, and we can determine its slope, and it's right in front of us. So, again, very simple. We were given 9 and 10. We were simply given 2 different types of problems, but they all led to an equation with 2 variables, which we then are able to graph by simply putting it into slope-intercept form. So that is the end of lesson number 6.